Practice problem number 4 asks us which set contains only rational numbers. So each answer choice A, B, C, and D have a cluster, a set of 4 different numbers. We need the one that has 4 rational numbers in its set. So I'm going to first look at answer choices for A. If I take a look at answer choices for A, 2/5, that's a rational number. It's already a fraction. 3/5, that's a rational number. This is not a clean decimal, negative 5.769, but it stops. I know this came from negative 5 and 769 over 100. Our problem, the square root of 2 right here. The square root of 2 is one of our irrational numbers. It does not fit in our square root of 1, square root of 4, square root of 9, our perfect square root table. So the square root of 2 is the reason that answer choice A is actually not correct. It doesn't have only rational numbers. Answer choice B, negative 2 is an integer. We could just write that as negative 2 over 1. Square root of 16 equals to 4, which could be written as 4 over 1. So the square root of 16 is also rational. Negative 2/3 is already a fraction. And any repeating decimal actually comes from some fraction. So answer choice B is going to be our correct answer. All 4 of these we believe to be rational numbers. That means C and D should have an irrational number somewhere in them because we can only have one correct answer here. If I take a look at C, the square root of 38, if we did that out, the square root of 38 gives us an irrational decimal. It doesn't fit between square root of 36 and square root of 49. Pull it down there. So the square root of 38 is another irrational number. And for D, we see this non-repeating, non-terminating decimal. This is an irrational number, so those are how I end up knowing that these 3 numbers tell me why A, C, and D end up being the incorrect answers here.